This is the Kenwood BN-RK800. It's a portable power station. This one has 800 watt hours of battery capacity, and it has a built-in inverter that can give you up to 700 watts of AC current. So I purchased this guy for $200 US. All right, inside the box they have a please read this first, a box with some cables and things, I'm assuming, and then the actual unit itself. All right, the unit takes up most of the box. It has styrofoam packaging around it. And there is a handle here. The unit weighs approximately 25 pounds. The primary thing you need to know is it's not charged from the factory, or not fully charged when shipped from the factory. So please fully charge it before you use it. Also, don't get it wet. It comes with a 36-month Kenwood limited warranty from date of purchase, and it comes with a little quick start guide that basically says plug it in, how to read the gauge, charge it at least to 80%, and then how to get USB power out, AC power out, or DC power out by turning on the switches. All right, so there's only two cords that come with it. One is a AC power plug. It's kind of an IEC standard computer style plug here with a standard 120 volt US plug at that end. And the other one is to power it out of a car's cigarette lighter port. So this is the DC input, 12 to 26 volts DC, up to 240 watts. This is also solar capable. You can purchase solar panels with this plug that would just plug in there and start charging it. So the front panel has an AC power on-off, 3 AC ports. It says a total of 700 watts. Has a DC kind of car cigarette lighter port, maximum 120 watts output. There's a DC button to turn that on. And then it has USB, and it has a USB-C port that is 100 watts. It has another one that's 30 watts, and then it has 2 USB-A ports, and they say 18 watts times 2, so I'm assuming it's 18 watts each. And they are the Qualcomm Quick Charge compatible. There's also a light over here that works on it and a display. So I pushed the display button, and it's in eco mode by default. It's at 48% charge, so it came about 50% charge from the factory. There's some input and output watt displays, and then a time, which I'm assuming is going to be an estimate of how long it'll run. The light button does kind of a dim light, a brighter light, and then does kind of an SOS flashing, and then back off. So you hit USB, it turns green. You hit AC, it turns green. You hit DC, it turns green. And so you can activate or deactivate each of these ports as you go through. Now, when I turned on that AC, it started saying, hey, you have a 99-hour runtime. And so, it does take a little bit of power to run the inverter, even if nothing is running off of it. And I'm assuming that's kind of the similar for like the USB ports and the DC ports as well to some extent, although it's not popping up to like 99 hours left. Now, when you're in eco mode, if there's no output of power or a low output of power from any of these ports, they will turn themselves off after 4 hours. They say if you press and hold the display button for multiple seconds, the eco will go off, and now it's in regular mode, and I believe it will not turn itself off now. So now, even if nothing's plugged in, it'll just keep that inverter ready to provide power. Not too much on the rear panel. There's a circuit breaker. It basically pops out if you have too much power drawn. You push it to reset it. There's AC input where you plug in this cord and you can charge it. Now, the primary reason I purchased this particular one is it's advertised as having a uninterruptible power supply feature, where if you plug it into the wall and then plug devices into it, it will power them just using your AC wall current until the power goes out. And when the power goes out, then it switches over to using the battery and keeps them powered with the battery. So it works well as an uninterruptible power supply. Now, it's only a 700 watt output, so that's a decent amount for a UPS, but it's kind of a middle amount for a kind of battery bank or power bank. So the power cord is about 6 feet long, and it needs about 1.5 inches of clearance at the rear of the unit when it's plugged in. So there's no vents on the rear of the unit, but there are vents on both sides, and you should probably leave a couple of inches of clearance for air to flow in and out of those. So the charging circuitry is built in, and the power factor is basically 1. It's 0.99 power factor, so that's a very good power factor. Now, although the inverter can provide 700 watts out, it only charges at about 500 watts, so it's drawing 485 watts in. So my wall meter says it's drawing 480 watts. The display here says the input is 459 watts. So it's probably a little bit inefficient in converting AC to DC, so it's probably getting 460 watts DC in out of that 480 AC watts. A fan is turned on. It's relatively quiet, but it's stepping up, I think, as the temperature increases. So it's blowing out of the left-hand side, and it draws air in on the right-hand side. So the fan is definitely noticeable now. It's stepped up through about 3 levels, and it is, audible. Not super loud, but there's a fan blowing in there. All right, I've plugged a 500 watt load in, and so output here is, okay, it's giving 500 watts out. It says its input is 963 watts, and you can see here it's drawing 964, 965 watts. So it's charging the battery and powering an external device at the same time. Now it has an estimated charge time, and it says 0.8 hours, so 0.8 of an hour. Also, the AC input blue light is turned on, so it's plugged into AC power. I don't have anything going into the DC input port, so that light is off. Alright, I'm going to pull the AC power, and when I do that, my load still gets its 514 watts, but I don't get an input. And now it says, hey, your time is 0.6 hours, so I think that's basically I have half an hour of power at the 500 watt output level because I'm only 53% charged. So I'm going to plug in the AC and charge it up some more. But it does correctly handle switching AC power on and off and over to the inverter. I did hear a small click, so I believe it is passing AC power directly through to the output. It's possible it might be able to supply more than 700 watts when it's plugged in, but when you lose AC power, the inverter can only do 700 watts output. So it's probably best not to try to get more than 700 watts out of it at any point. Alright, so it's been putting 500 watts out to the AC output. It's bringing in 960 some watts, so it's doing 460 watts of charging while running a device on the output. Now the fan is blowing. It's kind of noisy, not super loud, but you can definitely tell it's there. The air coming out is just barely warmer than ambient, so it feels like it's doing a good job keeping things cool and getting any warmth out of the electronics that are in there. But it is, definitely you can hear that fan blowing. So this guy's been sitting here charging for about half an hour. It's warmed up a bit. You can see there's, the plug going into the wall has a little bit of resistance. It's gone up to like 102. The fan is doing a pretty good job. Looks like air coming out of there is, above ambient, but, 90 Fahrenheit. And then, the front panel, there's just kind of warmth in general. This is the air inlet fan. You can see it looks like there's some cells at the bottom that are a little warmer down at this part down here. And then the AC cord and the inlet there have a little bit of power. But all in all, this guy is barely above ambient. So it doesn't look to have any trouble. It's putting 800-900 watts through it, a couple hundred into the battery and then 400 into the output here. So thermally it seems to be doing just fine. So the front display says it's 97% charged, but if you look at the input and output watts here, it's putting about 450 watts into the battery pack still. So I think that the battery pack is capable of charging at a pretty high rate, and the charger, the onboard charger, is kind of the limiting factor there at 450, 500 watts. All right, so this guy is fully charged, 0 watts in, 0 watts out, says 100%. This fan is still going. It's been going for about 30 minutes. Unplugged it from AC, fan's still on. Might be a temperature thing, might be, hey, wait until the AC to DC charger cools down, wait until the battery pack cools down. But fan's still on. So it's been sitting here for 20 minutes, nothing plugged in. The DC, AC, and USB are all turned off. Still a slight fan noise, so it is using some battery power to cool things down. Alright, about an hour after it was done charging, the fan has turned off. Alright, we're going to try this guy out with a load that's higher than its rating. So there is this load here. Got an error because it drew too much power. Turned off the AC, turned it back on, it cleared the error. So I've plugged in my refrigerator. The compressor isn't running yet, and this guy here at 700 watts definitely won't run every refrigerator. My refrigerator is an Energy Star, and usually it's only 400, 500 watts, so I'm hopeful it will be able to run it, and we'll see how long it goes, and this guy will keep track of how much power it puts out with 100% charge. Alright, as soon as this guy dropped below 5%, we got a little red low battery indicator. No beeps, no buzzes, no flashing, but we do have that little indicator. Alright, this guy shut down. It didn't like hang around at 0 for a long time. By now I'm sure it hit 2%, but it just shut off. Total runtime was just over 7 hours, and in that time it delivered 530 watt hours of power. Alright, pushing and holding the display button. It is not reacting at all. I'm going to hold for 15 seconds. It appears to be completely dead at this point. So we're going to charge it back up, see how many watt hours it takes to charge up. Alright, as soon as I plugged it into AC power, I heard a couple of relays click, and it is incrementing this little percentage mark here. The red battery light is flashing. I'm getting clickings. I'm not certain. I suspect this might be some type of initialization sequence as opposed to the amount of battery capacity. It is plugged into AC power right now, but we're getting 0 watts input on the input meter. I did see a little error there, but then it went away. According to my meter, I do have 114 volts at that outlet. The blue AC power light is not turning on. So I am going to reset it. I'm going to hold the display button for 15 seconds. It seems to be confused about the charge level. Obviously it can't be at 100% because I just ran it down all the way. So I've left it plugged into AC power, and the AC input light is not currently on right now. I'm going to turn on this light and see if that reduces voltage enough for it to realize it needs to be charged. So this seems like a problem, because if you didn't know that you just discharged it, you could check this and say, hey, I'm fully charged. You start drawing power out of it, it's probably not going to give power for very long. So currently it is drawing 2.8 watts, probably just to run the AC to DC charging circuitry. So it's definitely drawing a little bit of power out of the AC line, but it's not charging the battery right now. And it's certainly drawing less power than it's putting out. So all of this watts out to this USB-C device is via the battery. Aha, we just had something happen. So this number ramped down to like 80%, and now it's starting to charge. And it turned off the USB power outlet, and now it's starting to charge. So it's drawing, well, the number of watts it's drawing is changing up and down. There, it's drawing 447 watts. It says 420 here. So now it is charging, and it's estimating, 1.5 hours. If I turn on USB-C again, it'll start putting out power here. Alright, and now that it's charging, the fan has turned on. I did not hear the fan turn on at all while it was running my refrigerator. I've plugged in a device that can charge it up to 100 watts. And so I'm testing the 100 watt USB-C power delivery outlet, and it is putting out 95 watts. This guy here says it's getting 93 watts. So it's pretty darn close to meeting that 100 watt specification. Alright, and the battery was at like 4% when it shut off, so it's really not at 83%. So I think it's going to be charging maybe a little longer than its estimate here, but it is charging kind of full speed, 400 and some watts. Alright, this guy took just over 2 hours to fully refill the battery, and it took 890 watt hours to fill it up. So the battery capacity is supposed to be 800 watt hours, so that sounds about right. It only delivered 530 watt hours out through the AC inverter, so there are some efficiency losses going out through the inverter. Alright, I've put this guy through its paces. I'm pretty happy with it, especially at the price. So the most direct competitor comparison here, I think, would be the Jackery 1000 version 2. That unit is just about the exact same size and weight. It has a little more battery capacity, so it's about 1,000 watt hours instead of 800 watt hours capacity. The big difference that you're paying twice as much for is it does 1,500 watts AC out of the outlets, and it'll surge to 3,000 watts. So that means it'll run pretty much any household appliance. You don't have to think about, well, is it under 700 watts or not? So if you need to be able to run a microwave, for example, or a refrigerator that's not an Energy Star refrigerator, you might have to pay a couple $100 more to get a little more capable unit. Or if you just want the extra 250 watt hours of battery capacity. Another advantage is it charges a little bit faster. And it also has an app. There's a few things you can do with the app that this guy just doesn't support. So you can say, hey, don't charge the battery all the way up when you're in uninterruptible power supply mode. But other than that, at half the price, or a little less than half the price, this guy has decent battery capacity. If you're just using it in UPS mode to do smaller electronics, like I'm planning on using this for my DSL modem and Wi-Fi, and so it's more than capable for that. And the price definitely comes in a lot cheaper there.